Welcome viewers to the SD online classes. Today we are continuing the second episode, that means second class in this chapter, chapter number 3. The chapter number is 3 in class 9 MBSC physics portion. The topic that we are doing in this chapter, gravitation and flotation, is Newton's third law of motion and gravitation. Okay, here what we are going to do is that suppose there are two objects, m1 mass and another object m2, then what will happen, these two will attract each other with force F12 and this will attract this object with F21. F12 means force on one, this object m1, due to the presence of this object m2. Similarly, F21 is this object also is pulling it this side, F21, that is the force. Okay, now how we will connect here is that F12 is force exerted by m1 on m2 and F21 is force exerted by m2 on m1, this one. And also what we know is the force, these forces are equal and opposite in direction. Okay, this, see, look at it, this is going towards right side, this is coming towards left side, so they are equal. F12 and F21 are equal but opposite in sign, minus. Okay, so now this is the third law of motion, also says the same thing, the equal and opposite force. To every action there is equal and opposite reaction. Now if we want to determine the force between earth and moon, it has to be assumed that all the mass of these two bodies are concentrated at the center. This also is important, that the force when calculated must be assumed that mass is at the center. This is also important, okay, because this is always calculated from the center. So this is about the connection between Newton's third law and gravitation. Okay, the second particle, first particle, second particle, they are pulling each other. Now the next topic in this will start from here. Free fall. What will happen when object is falling? Free fall means one object is there which is falling down. Okay, this is the object, suppose m1, like this. Okay, let us see what is free fall first of all. So let's try to understand. Gravity is free fall is that, free fall means it is that fall, suppose one object is moving down and there is no other thing acting on it. Okay, we are not throwing it, we are not pushing it, nothing, but only the earth, that means the floor is pulling it. That is, gravity is the force with which the earth pulls any object downside, is called the gravity force. If this is happening, we call it, it is a free fall. You can understand, free means no other thing, nothing is disturbing it, it is just falling by its own. So this is called free fall. Okay, there are examples of free falls. What are they? Number one, suppose a ball dropped gently. Suppose one object is dropped from some height, nothing is done. What will happen here? The velocity is 0. You see clearly here, the velocity is 0 because nothing is moving. Here when it reaches here, the velocity will be slightly bigger. Now when it reaches here, the velocity gets more. When it reaches here, the velocity becomes bigger, but when it will hit the ground, the velocity is the biggest. Okay, the velocity is highest here. So this way the velocity is increasing down. So this is called free fall example, one example. Okay, there are other two examples also. Number two, what is the second case, how it is? There is another type. Another type is that, suppose you have a ball, you throw it upside like this and after some time it comes back and falls back. Okay, this type. This is also an example of free fall. Why? Because when you throw it vertically, vertical means up and down. If you throw it in the air, on the way what happens, the velocity will decrease, slow and stops, and then again increase. But here you see no other force is acting, only the force with which the earth is pulling it back is only acting. Even when it is going up also the earth is pulling it, when it is coming down also the earth is pulling. This type of is also an example of the three case where free fall happens. Okay, there is one more case, the third case. Now this is the third case. I am not writing the detail what is happening. Okay, in the third case, first case you drop it, second case you throw it, and the third case is like this. Suppose you are here and you throw a ball in this direction. Okay, this is horizontal direction. What will happen after some time? The ball will start traveling in this direction. It will stop travel in this direction, horizontal direction. It will slow down, slow down, slow down, and after some time it will fall in the vertical direction. Okay, so this is also where you can see that the motion, the direction is also change, making the change because of the acceleration of caused by the earth. Here is the earth, in this case here is the earth is making the body to accelerate, means change the velocity. See, increase, increase, increase the velocity. Here decrease, 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 and increase, increase, increase the velocity. Now that means accelerate. Accelerate means gravity is there, force is there. Here when you throw something, it will go and go, and its direction will change. If direction is changing means the velocity is changing. Velocity can, remember, velocity can change even if the direction is changed. Now direction is changed, see, it is going from left to right, but suddenly after some time it will go downside, up to downside. So this is a three different examples where gravity is acting. Okay, gravity is acting on this ball. So these are the ways in which we can see and understand free fall. Okay, next topic will be, the next topic is acceleration due to gravity. So what happens here? Let us see. In acceleration due to gravity, it is also denoted by g. You see the name acceleration a, but when it is due to gravity, then we will call it g. Okay, not a. So what is this? It is the acceleration, it is the acceleration produced in the motion of a body under the effect of, means due to effect of gravity. Gravity is the force, acceleration due to gravity is the acceleration. Okay, the acceleration produced in a motion of a body due to the gravity is called acceleration due to gravity. Okay, it's denoted by g. Now we will write what is the example. From Newton's law of gravitation, we studied in the previous video, if you remember. Newton's law of gravitation says that if m is mass of any object, m is mass of earth. Suppose this is the earth, on it another object is kept, maybe a human. Now from here the center of earth is here, capital R. Suppose this is the center, and this is m, mass is m, the bigger mass is m, capital M. And then what will happen? Force of attraction will be how much? F is equal to g m1. This, see, m1 is m here. Okay, m2 is small m, and divided by what is the distance between them? It is from here to here r, and this is very small, so we consider it to be r only, r plus very small there. So this is r square, right? So now here we know on the mass m acceleration is produced, acceleration produced, suppose we call it g. Then what is the formula of force and acceleration connection? Force equal to mg, right? Force is equal to mass into acceleration, just like that in the second chapter we studied. Force is equal to mass in Newton's second law. So this says this is like this. Suppose this was your equation 1, then what will happen? If that is the equation 1 and 2, you can see their left hand side is same, therefore so from 1 and 2, f equal to this, f equal to this. So what you will get? Mg equal to gmm by r square. Look at your textbook. In your textbook, this m may be given a mistake, okay? In the next one, I'll tell you where. This m and m will cancel. So you will get small g equal to gm by r square. This line is a typing mistake in your textbook. You can see this m is written small m. This should be capital M, okay? This is the formula of acceleration due to gravity, which will remain same, okay? And what is r? You know r is what? R is radius of earth. What is m? Mass of earth. What is g? Universal, its value also is known, gravitational constant, right? Now replace all the values, what you get? G value will be, so G will be equal to, G is 6.67 into 10 to power minus 11 into, what is m? Mass of earth is 6 into 10 to the power 24 kg, divided by radius of earth is 6.4 into 10 to power 6, okay, meter. So it's square. So all this if you do, it will give you 9.8 meter per second square. If you multiply these two numbers, if you square 6.242 times and then cancel it and simplify all the things, you will get 9.8 meter per. This is the value of acceleration due to gravity, okay? So this much we understand in acceleration due to gravity, okay? So you have to remember that mass, here I'll write here somewhere, m is 6.67, g is 6.67 into 10 to power minus 11 Newton meter square per kg square. M is what? Mass is 6 into 10 to power 24 kg and radius is 6.4 into 10 to the power 6 meter. So these are the things, right? This is all about acceleration due to gravity. Now in the next video we will do further on this. Thank you.